Right, in this screencast, we're going to look at how to find the distance between two parallel lines. So we'll have one line of y equals 3/2 x plus 6, and the other line is y equals 3/2 x minus 1. So what you don't want to do is just look at them and see that their y-intercepts are 7 units apart and say that that's the distance, because that distance is not the shortest distance, it's not the perpendicular distance. Instead, if I look at y equals 3/2 x plus 6 and y equals 3/2 x minus 1, I can see that this distance is not going to be the shortest distance. So I don't want to use that one. Instead, we're going to have to look at a perpendicular distance, and I'll go ahead and draw that in here. Put that into orange. We want to find the length of that orange segment. Now, what do I know about that orange segment? Well, first of all, it's perpendicular to both the blue and the red one, so the slope of that segment is going to be equal to -2/3. It has the same y-intercept as the top one. That point is 0, 6. So the equation of that orange segment, if I turned it into a line, would be y equals -2/3 x plus 6. The reason why that's significant is because we want to find out where does that orange intersect this red. We want to figure out what are the coordinates of this point right here. So we want to know where does this orange line intersect the red line, which is the equation y equals 3/2 x minus 1. So we'll set 3/2 x minus 1 equal to -2/3 x plus 6 and look to solve that. Now, what I generally do in a problem like this is get rid of all the fractions. I don't want any denominators. The least common denominator would have been 6. So we're going to multiply everything on both sides by 6. Gives us 9x minus 6 is equal to -4x plus 36. And now we'll solve this for x, so add 4x to both sides, add 6 to both sides, divide both sides by 13, and we have this very ugly fraction of 42/13. That's the x value of this point. To find the y value, we're going to plug it into either the orange equation or the red equation. It doesn't really matter which one. I'll just choose to plug it into this one. So y equals -2/3 times 42/13 plus 6. And the problem probably isn't going to get much uglier than this. As I'm looking at this, I see that I can simplify, divide that by 3, divide that by 3 to simplify it a little bit. So y equals -28/13 plus 6. At this point, I'm going to go to the calculator and add those together, and that fraction is 50/13. So the coordinates for this point then are 42/13, 50/13. All right, so then I'm going to go ahead and clean this up a little bit. Let's see if I can choose that. We'll take all this and minimize it. Now, the last thing we have to do in this problem is figure out what is the distance between those 2 points. And so I'm going to use distance formula. Distance is the square root of 42/13 minus 0 squared, so it's just 42/13. And then 50/13 minus 6 squared. When we square the first one, we'll square the numerator and square the denominator. And then to take 50/13 minus 6, that is -28/13. So when we square that, that's 784/169. Now if we add these together, we get 2,548/169. So this is the distance between them. However, this does need to be simplified. The denominator is just plain old 13, and then I want to break down the square root of 2,548. I'll divide that by 4, because 4 is a perfect square. And I have the 637. Now, I'm not really sure what goes into it, but as I look in the denominator, I have this 13. So I'm going to divide by 13 because I think 13 probably goes into it. And in fact, it does. 13 times 49 is 637. So when I look at breaking this down, we have a 2 on the outside, we have a 7 on the outside, and square root of 13 is left on the inside. So our distance is 14√13/13. Kind of an ugly problem because of all those numbers, but this is the distance between those two parallel lines.